Aloha and welcome to Discovering Earth's History video. In this video, we'll list the three main ideas that geologists use in studying Earth's history, we'll list the key principles of relative dating, and we'll describe how geologists use inclusions, unconformities, and correlation of rock layers to interpret the rock record. So when we study the Earth's history, we can actually use the rock record, which is the rocks that are there, and that'll allow us to paint a picture of what has happened in the past. In order to do that, we have to have a couple agreements or a couple ideas that we all hold to be true, and that allows us to use these ideas and carry them over so we can understand what the rock record is trying to tell us. The first of these is that the rock record is going to provide evidence of geological events and life forms. So this allows us to say that the rock record is actually going to tell us what's been going on, and that makes it kind of useful. The second is a process that was presented to us by James Hutton of uniformitarianism. And what it basically says is that the processes observed on Earth today also acted in the past. So there's not some new processes that were happening now or some that no longer happened that happened in the past. The same things that shape the Earth now are the same ones that shaped the Earth then. And then finally, that the Earth is very old and it's changed over geologic time. So we've had time for all of these things to happen. So using these three ideas allow us to study Earth's history and the rock record. Now, when we talk about dating, there's several different kinds. The first one is going to be relative dating. And relative dating doesn't give us exact dates. It just kind of lets us say that this layer is older than that layer, or this layer is younger than these two layers. It allows us to age things relative to the other layers that are around it. Now, for us to be able to do that, we have three different laws that we use. The first one is the law of superposition. And the law of superposition can best be described in this type of example. What it's saying is that if we have multiple layers of rock that are undisturbed, the younger ones are going to be on top of the older ones. So let me show you what that means. Let's say you go to school on Monday, you get home, your clothes smell like school, so you take them off and you throw them in the corner. So you have Monday's clothes here in the corner. Then Tuesday comes and you do the same thing and you take Tuesday's clothes off and you throw them in the corner over here as well. And you do the same for Wednesday. And we throw those in the corner. Now what we know is that we have Monday on the bottom, we have Tuesday above that, and then we're going to have Wednesday's clothes on the top. So the oldest layer is going to be Monday, and that's going to be on the bottom. And the newest layer will be Wednesday, and that's on the top. And that's what the law of superposition says. And it kind of makes sense. We can't lay down a rock layer on top of nothing. It has to happen on one that's already been there before. The second one that helps us is what we call this principle of original horizontality. What that means is that we're talking about sedimentary rocks here, and those are the layers that we're going to be looking at. And what we notice is that sedimentary layers are going to want to lay down in a horizontal manner. So originally, that's what they're talking about. It's all these layers were going to be this way, and they'll stay that way unless they're acted on by a force. So if we see a bunch of layers that are looking this way, we can assume that the oldest are at the bottom and the youngest are at the top. And then our third and final principle is this principle of cross-cutting relationships. And that one makes a lot of sense if we look at the picture. And what we're basically saying is if we look at this fault here, we have fault A. Notice that fault A is going to break through these layers, but not this one here. So that means that for it to break through the layers had to be there before it. So that'll allow us to say that this conglomerate layer is going to be younger than this sandstone layer because the fault doesn't go through it. And the same can be true for not only faults, but also if we have igneous intrusions like this dike coming through here or a sill forming here. Now, when we use all three of these principles or these laws, it allows us to age our layers based on their relative age to each other. So we can't get an accurate age. We can't say that this layer was this many years ago, but we can say it's older or it happened before this layer. And that gives us the benefit of just kind of relatively aging things. Now we have two other clues that allow us to read the rock record. One of them is inclusions, and inclusions we can see down here, this inclusions of igneous rock. What we're looking at is these bits and pieces. So if we have bits and pieces of something inside, then we know that this layer had to be here first so it could break these other pieces off that could then be incorporated into the layers above it. So we know that below is going to be older again. Now, the other one we talk about is you'll hear these unconformities. And unconformities are where we have gaps. So if we see that we had this yellow layer here and then a blue layer here and then this kind of browny layer here, notice how they've eroded away. So as they erode away and we have this missing part of the rock layer, that's what we'll call an unconformity. And both of those kind of help us read the rock record. Now here we have a cross section of the Grand Canyon, and you can see where we have some of these unconformities. And what that means is we're coming up here and we're going to have these, like this angular unconformity, these gaps in the rock record. These are going to be breaks where it doesn't necessarily match up with the rock layers that are there. And that kind of helps us gauge and estimate ages and other geological events. Like if we had sedimentary rock, but then suddenly it dried out, we're not going to have more sedimentary rock forming until we get that water come back in and allows that sediment to settle. Now, if we look at rocks in different areas, we can have this correlation of rock layers, and that kind of paints a better picture for us. If we have the Grand Canyon here, heading up the Kaibab Plateau, we get to Zion National Park. And what we notice here is that we have this Kaibab Limestone layer, and we can see that here as well. And then we have this Moenkopi Formation that's above it. We'll see that there. So what we can do is we can start to match these. We can correlate these, and we can then say that these formations would actually be up here, but they've either eroded away or they were no longer an area where sedimentary rocks could be laid down in the Grand Canyon. Okay, so that's a quick introduction to the rock record. As always, the lessons will explain it a little bit better for you. Good luck on your quizzes, and we'll see you in the next video.